All right, so let's work through an example. Let's say we had a CD and a CD player, and this thing is spinning around. We'll say in this direction. So it's spinning around. The diameter of this, so all the way across, is 122 millimeters, and it's spinning at 540 RPMs. So the first question we can ask is how much time does it take to do one complete revolution? And so to do that, we're going to need the time it takes is period. So the period is going to be 1 over the frequency. And so we need to figure out the frequency. And frequency is given by the, remember that frequency is the inverse of your period. And so what we're going to do is we actually won't use this. We can just, it's given to us right here. This is our frequency. So the frequency is 540 revolutions in 1 minute. But these aren't standard units. So what we're going to do is we're going to change this minute. 1 minute is 60 seconds. And doing that, you get 9 revolutions per second. And revolutions, that's not a real unit. So what we actually have is that it's 9 to the inverse seconds. That's our frequency. It's -1. 9 to the negative. So that's our frequency. So if I want to know how long it takes to do 1 revolution, I just divide that by the frequency. So that'd be 1 divided by 9. And again, that's inverse seconds. So the seconds go up top, and that gives me 0.11 seconds to do 1 revolution. Yeah? Okay, so now what if we said, okay, well, say there's a little speck out here on the end, and it's going to go all the way around. How fast is this thing going? If it goes all the way around in a complete revolution in 0.11 seconds, how fast is it going? And so velocity, and you're not going to have an equation on your equation sheet for velocity, but if you just know the definition, velocity is going to be how far did it go and how long did it take. So all the way around would be the circumference of a circle, which is 2 pi r. And then we would divide that by the time, which is the period, t. So now we need to get the radius. Well, I don't have the radius, I have diameter. And it's in millimeters, so we need to do some conversion here. So 122 millimeters divided by 1,000, that's a 0.12 meters. And so the radius is going to be the diameter divided by 2. So it's 0.12 divided by 2, which is 0.06 meters. So that's my radius. So now I have all my numbers. So the velocity would be 2 pi times 0.06 divided by 0.11. You calculate that and you'll get 3.4 meters per second. So that's the velocity of a particle on the outside edge. Now if it was in the middle, I could then divide that by 2, and so I'd do 0.03, and that would tell me the velocity if I was on the inside. All right, so we have period, we have frequency, we have velocity. Why don't we do acceleration? So the acceleration in a circle, remember, is centripetal acceleration, and that's defined as v squared over r. So you can see it's just a substitution. So v squared, that's 3.4 squared, divided by the radius, which is 0.06. So you get a centripetal acceleration of 190 meters per second squared. So big acceleration, but that makes sense. It's a small circle, so this thing has to whip around really fast at 3.4 meters per second. So, but that's it. So these are the types of problems that you'll have to be able to deal with going from one to the other. You know, give you acceleration, you tell me the velocity, that sort of thing.